10. And we're going to go 4 higher than that, so I'm going up as far as 14 meters. So here's the thinking that I need. We're going to take a slice of water. Remember how I made you slice those shapes that we did, our volumes of solids of revolution? I need you to take a slice of water and I want you to think about moving that slice up and then up 4 more. So that's what we have to worry about. Now in terms of the force on that little piece, we're going to need to know about the weight, because when you compute the weight of water, it's whatever the volume is times the weight. That's going to give us the weight per whatever unit you're working on. That'll give us our force. So now when you take this out and look at it, it's really it's a circle, right? So if I talk about the volume of that little disc, it's going to be the area of that circle times the thickness, and this is a thickness of dy. It's along my y-axis. So my volume is going to be pi r squared. There's the area of the slice times the thickness of the slice. Now that's the volume of just this one little slice. But I know that water, whether you know it or not, water weighs 9,800 newtons per meter square. This is water. In the homework, he's got them with pounds and feet, so you might need this number also. Just tuck it in with your notes. That's pounds per cubic foot, 62.4 pounds per cubic.
Memorize this number?
No. But if you come up with another one you need, you should be able to Google it and find it, okay, I think. But these are the 2 main ones that people use. Okay, so what I've got to do in order to get my actual weight of this thing, I'm going to have to multiply, so the weight is going to be the volume of a slice times the weight per slice, or the weight, I don't know how to tell you this. Well, this is in meters. When I do this, that's meters squared times meters, so this is really cubic meters, and I'm going to be multiplying it times newtons per meter squared, so I need to use this 9,800 figure. So I'm just going to put 9,800 in here. Hopefully that'll make sense to you. Now, actually, we can do better than this. What's the radius? Yeah, the radius is 5. So I've really got pi times 5 squared times dy times 9,800. There's my slice. Work is going to be the force, which is the weight, times the distance I have to move that slice. So if this slice is up at y, 10 minus 4, worse than that, I got to move it 4 feet. Oh, yes, I got to move it 4 feet farther than the 10. So it's got to be 14 minus y would be the distance I need to move that slice. So my work is going to be pi times 25 times 9,800 times 14 minus y dy.
May I ask a question? So the work that it takes to get out of the tank in the water, and then the work to get above the water is equal enough to not like have to separate it from like that part when you're in the water to like when you're out of the water? Do you know what I mean? Because I would think it would be easier for water to move out of, like, it's the same.
It's the same. Yeah. But I am going to attend to the fact that the slices only exist
In the water.
in the water.
And cylinder.
And that's my limits of integration. So my slices, I only have to slice from 0 to 10. So it is accounted for, if that's any more appealing to you. And now you go fint and get an answer. So if you'd make yourselves a note to say that this is where are the slices, where are the slices, and this was how far does a slice move? And if I can get you to get that, the rest of the homework will be a piece of cake. Those are the two stinker things. Where are the slices and how far does a slice move? Yes?
So if we get this, that slice is pi r squared, you know, right?
That-
slice?
Yes, and actually that would be the slice anywhere up and down there because this is the same radius all the way up. In a minute we'll do the one where the radius isn't the same all the way up. And they won't always be cylinders. They could give you a square tank, but that'll be okay too because you know the area of a square and then times the thickness of a slice. So the regularly shaped things aren't too bad. So let me see what I didn't even write down what this came out to be. Something big enough, but you should be able to finish.